The objective of this video is to make you write any algorithm using singly linked list, but we have taken the process of insertion for this purpose. In each slide, we have the algorithm and the Python code associated with it. So what concepts do we cover in this video? We see what we mean by the word node. We see how to create a node, how to insert a node at the beginning of a list, how to insert a node at the end of a list, and how to insert a node after a given element. ABC is setting up an electrical appliances store, and for that, they store the product ID and the name of each item in the store. So, we have a list of elements where each element has a product ID and a name, and these list of elements are to be stored as a linked list. A linked list can be used to store a list of elements. The list of elements have already been given in the previous slide, and to represent the list of elements, each element is stored in what is called as a node. A node is composed of two parts, namely the data part and the address part. When we look at the problem statement, the data part consists of PID and name. But in the address part is what is going to tell us that all these elements are part of the same list. So we link one element in the list to another element in the list. We can link any element in the list to another element in the list. So we can have multiple address parts. Similarly, we just saw that I can store any number of values in the data part. So I have multiple data parts and I have multiple address parts. The simplest linked list that we come across is called as a singly linked list. In a singly linked list, there is a restriction on the number of elements in the address part. In a singly linked list, there is only one element in the address part, and that element stores the address of the next element in the list of elements. Node is typically used to represent an element in the linked list, and as you can see, 100 and tap form part of the data part, and null is a pointer to the next element in the list. And when I use the constant null, I refer to the fact that this node is not pointing to any other node in the list. It means that there is only one element in the list. We just got introduced to a new word called as node. Another major thing that will be required when we talk about linked list is a pointer, and this pointer points to the first element or the first node in the list. We are going to use the variable name start to denote the first element in the linked list. When the value null is stored in start, it means that the linked list is empty. Knowing the value of start, I can move from the first element in the list to the entire set of elements in the list by just knowing the address of one node, which is the starting node of the linked list. That is, passing the address of the start node into an algorithm is equivalent to passing the entire list, which is stored as a linked list. Some of the notations we will use are the assignment operator is given by the backward arrow, and when I want to access an element inside a node, I use a forward arrow. An example is taken. The first element is taken in the list. The element in the list is composed of two data parts, 100 in PID and tap in name. And this is the first element in the list, so it does not point to any other element, and so we use the word null in the place of the next address. Let us see how to represent the data parts, the address parts, and the start all in terms of an algorithm. Start stores the value 10, that is the address at which the node is stored in the memory. When I want to access a part inside the node, the only way I can access it is using a pointer to the node. Here start is a pointer to the node and stores the address of the node, which is 10. So to access PID, I have to use start arrow mark PID, which I typically would say as start of PID. And to go to the address part name, I give start of name and I can store the value tap in it. And to store null in the address part, I give start of next address and store the value null. Next address also stores a pointer value. Start also stores a address value, but start points to the node and next address is part of the node. To access any part inside the node, the pointer to the node must compulsorily be used. Let me now insert the second element in the list. So when I insert the second element in the list, let me call that element as current. That is the address of the node in which I store 101 and cap and null is at the location 50. And the value 50 is stored inside a pointer variable current. Current now stores the address of the node. So current is equal to 50. To access 101, I say current of PID, and to access cap, I say current of name, and to insert the value null, I say current of next address. Start of PID stores the value 100 because start stores the value 10, but current of PID is 101 because current stores the value 50. We say start points to the first node and current points to the second node. So what do we mean by the term link one element to the other? If at the next address in a node, I store the address of the next element in the list, it is equivalent to telling that one element in the list is linked to the next element in the list. In start of next address, I have stored the value 50. So it is linking to the node which is present at the address 50. The node at the address 50 stores the value 60 in the next address. That is, it is pointing to the next element in the list, which is stored at the address 60 in the memory. When the last element is inserted, the third node points to the fourth node by storing the value 20 in the place of the next address. Let us see in detail how to insert the following elements in a linked list. The first step is to initialize an empty linked list. That is, we initialize the value of start to be null. When we write the corresponding Python code, we make use of two classes. The class node is used to represent the individual elements, and to represent the entire linked list, we make use of the class singly linked list. Let us create our first node. Creating a node is to allocate space in the memory for a node and to insert the values in the data part and in the address part. We write a function called createNode that takes the item as the input. First, getNode is used to allocate memory for the node. Then, in node value, we insert item. It is similar to writing self.value is equal to item in Python. This takes 14 bytes of space in the memory. This element does not point to any other element, and so we store null in the next address. This is similar to storing none in Python. In Python, next address uses 8 bytes of space. How do we create a node when there are two data paths? I refer to the first data part as data 1 and the second data part as data 2 and store PID in node of data 1 and the second data part in node of data 2. The simplest way to learn insertion in a linked list is by inserting at the beginning of the linked list. First, we create a node and store the address of the new node in the variable new node. We store the value 32 and the value null in the next address pointer. Initially, start is at null, that is the linked list is empty. Now this new node has to be inserted as being part of the list of elements in the linked list. So we make start point to the new node. This ensures that this new node is now a part of the linked list. Next, we store the element with the value 45. We create a new node and then store the address of the new node in new node. Now this new node has to be part of the linked list, for which we store the address of the first node in the next address of new node. This ensures that new node has a link to start. Now we have to change the pointer to the first node. We ensure that the new node is now the first node by storing the value of new node in start. Now the linked list looks as follows. We now need to store the value 12. We create a new node, make the address point to new node, and then in the address part of new node, we store the value of start. This results in a link between the new node and start. Then change the value of start to point to the first node in the list. Now the linked list looks as follows. The same concept is followed to insert the node 56. We create a node, insert the value 56 and null in it, store the address of the node in new node. This is done in create node. We store the address of the first node in the linked list in the next address of new node. We change the value of start to point to the new starting value of the linked list. The entire algorithm looks as follows. In line numbers 2, 3 and 4, we create a node. In line number 5 and 6, we link the new node that was created to the existing linked list. When we convert the algorithm to a Python code, we create a class called as node to represent the different elements in the linked list and a class singly linked list to represent the entire list of elements in the linked list. Add first is the function used to create a node and to link the various elements in the list. Now that we have created the linked list, let's see how to print all the elements in the linked list by moving from the first node to the last node in the linked list. Moving through every node or every element in a list is called as traversal. Start always points to the first node in the linked list, and at no point should we change the value of start because we will lose the pointer to the first node in that case. So to traverse through every node in the list, we use another temporary variable called as current. Start always points to the first node in the list. Current keeps moving between the different nodes in a list. Current stores the value in start. To make current move from the first node to the second node, we have to store in current the address of the second node. Current is currently pointing to the first node. So the address in current is 148. But current's next address stores the address of the second node. So current is now reassigned the value 208 by assigning it to current of next address. Let us have a slight recap to check if we have understood what is in current and what is in current of value and so on. What is printed when we print the value in current. Current stores the address of the node that it is pointing to, and the address of the node is 208. Current of value stores the value 45. Current of next address stores the value 580. The values that I have written here are the values that I got when I implemented the corresponding Python program, and the address is given in a hexadecimal format. Now, how do I move current from the second element to the third element? Now, current of next address stores the address of the third element. So, assign the value in current of next address to current. This results in the current pointer moving to the third element. To move from the third element to the fourth element, I have to make current point to the address in current's next address. That is, store 7C0 in current. This results in current moving to the last node in the list. The corresponding Python code would look as follows. To print the linked list that we have already created, we start from the first element. So make current is equal to self.start, and then continuously iterate or traverse through the nodes in the linked list using the line current is equal to current.nextAddress. This is continuously done till current becomes none. When current is none, we have come to the end of the list. The output for the Python code shows the address at which the first element is stored, which is 160. It shows the address at which the node with the value 32 is stored, which is the first node at the location 160. The second node is 45 and it is stored at the location 208. The third node has the value 12 and is stored at the location 580. The last node that is inserted is stored at the location 7C0. Though 56 is the last node inserted, because the elements are inserted at the beginning, this is now the first node in the linked list. The first algorithm that we saw was to insert the elements at the beginning of a list. Now, what happens if I have to insert the elements at the end of the list? Inserting the first node in the list is to be treated as a special case. We have to first check if the linked list is empty by checking the value in start. If start is null, it means that the linked list is initially empty and the node that we are trying to insert is the first node. Create the new node. Let us assume it is stored at the location 148. Make start point to the new node. That is, store the value 148 in start. Before insertion, we need to check if we are at the last node so that we can insert after the last node. As shown in Traversal, traverse from the first node to the last node and make current point to the last node in the list. Next, we insert the node that we have just created as the last node. The new node is stored at the location 7C0. The data part has the value 56 and the address part has the value none to show that it does not point to any other node. Start from the first node in the list. Keep moving current till you reach a node in which the next address is none. Current now points to the last node in the list. Make the last node in the list pointed to by current to point to the node new node. That is, store the value 7C0 in the place of none. That is, current of next address is equal to new node. After insertion, the linked list looks as follows. To summarize, we first create a new node shown in line numbers 2 to 4. We check if the list is empty. We check in line number 5, and if the linked list is empty, we insert the new node as the first node, shown in line number 6. Else, we use a temporary variable current to move from the first node till the last node, and when it reaches the last node, the new node that we have created is inserted after it. The corresponding Python code is as follows. We create the node using class node. We create the singly linked list using class singly linked list. We check if self.start is none to check if the linked list is empty. And we check if current is pointing to the last node by checking current.nextAddress as none or not none, and assign new node to current.nextAddress. As shown under traversal, the linked list is traversed from the first to the last and the elements in the list are printed. The output shows the address at which we have start, the address at which we have 32, which is 148, the address at which we store 45, which is 208, address at which we store 12, which is 580, and so on. Let us improve the algorithm a little more. We are not restricting the insertion to be at the beginning or at the end, but rather we give the value of an element in the list, and if that element is present in the list, then the new node that we need to insert is inserted after that node, and if the element is not present in the list, then the new node that we want to insert is inserted as the last node in the list. As in the previous case, if the linked list is empty, we initialize it as the first node, the new node. If the element is not found, we search for the element using if current of value is equal to search element. Search element is the element that we are searching in the linked list. If the element is found, let us see what to do a little later. Else, it means that the element is not found in the list, in which case current moves to the last node in the list and the new node is inserted after the last node. This we have already seen in the earlier algorithm. The third case that we are considering is the new case, wherein the element that we are searching for is present in the list. Let us assume that the element we are searching for is 45. Initially, current is at the first node. When current is at the first node, the value in current of value will be 32. So, it will not match with the search element. So, current moves to the next element. Now, the search value is 45 and the value in current of value is also 45. The value that we are searching for is matching. Now, I have to insert new node with the value 56 in between the nodes with value 45 and 12. We know that the node following the new node should be the node with the value 12. So, in new node's next address, we store the value at which the data with value 12 is present. That is, in new node of next address, we store 580. Then we make the node with value 45 point to the node with value 56. That is, we store in current of next address the value of new node. That is, current of next address is equal to new node. This results in this final linked list. The insertion can be summarized as follows. We create the new node from line numbers 2 to 4. Line numbers 5 to 8, we check if the linked list is empty, and if so, insert the new node as the first node. Line numbers 9 to 15, we check if the element is present in the list or not present in the list. If the element is already present in the list, then we insert the new node after the element that we are searching for. We search and we check in line number 11 and insert in line numbers 12 and 13. If the node is not present, then we insert it as the last node. Line numbers 11 to 14 help us to insert in between. Line number 15 helps us to move the current value from one node to another if the search element that we are searching for is not found. We come out of the repeat while statement without returning if the element is not present in the list, and so in line number 17 we insert a new node as the last node. The difference between the previous code and this code is in the if-else statement. We first check if the value data is found, and if the value data is found, we insert the new node after the current node, else we continuously keep moving the current pointer till we come to the last node. The output for the code just shown will be as follows.